Hi and welcome back. This video is an introduction to compression. And in this video, I'm going to use a special waveform so you can see what the parameters of compression do to an audio signal. It's not going to be music. We're going to use a pulsed white noise burst, which doesn't sound particularly musical. Actually, it sounds just like this. But that's going to help us see what attack, release, threshold, ratio, and even the makeup gain do to an audio signal. So let's get started. I'm going to bring in the waveform. So this is what the waveform looks like. We've got basically two measures where each quarter note is a pulse of white noise, and it's at two different levels. So that basically gives us a loud level and a soft level, and then every other beat it changes. We've also specifically chosen 120 beats per minute for the tempo. The nice thing with that is that you can see every 2 beats is 1 second. So each measure winds up being 2 seconds long. That means each beat is 500 milliseconds. That gives us kind of a frame of reference in milliseconds as we're looking at attack and release. So what we can do is set up the compressor, and then we'll just bounce the result out to another waveform so we can compare the input to the output. So to get started, we're going to set the threshold. If you've worked with compressors before, you know they don't do anything until you lower the threshold to the point where the threshold's a little bit lower than the signal. So what we want to do is set the threshold where it's kind of like right in this range right here. So it's triggering on the edge of the loud part of our waveform. Then we want to set the ratio so that it actually does something to turn down the volume when it gets above the threshold. That's what a compressor does. So I'm going to set a ratio of 4 to 1, or right here it says 3.99 to 1, essentially 4 to 1. So for instance, a 4 to 1 ratio, if it's going 4 dB over the threshold, it will only allow it to go up by 1 dB. So right now I'm going to leave the attack and release set to the default settings here. And then all I'm going to do is render the file. Well, for one thing, you can listen to it here. That's with the compressor in. This is with the compressor out. Sounds pretty similar, but it's actually making quite a big change in the actual waveform. So I'm just going to bounce this to another track, and here is the output from that bounce. You can see that as the attack comes in, the volume is being turned down, and now we can actually see the effect of the parameter called attack. Attack is set to 16 milliseconds. So right here, we've gone over the threshold, and now over the next 16 milliseconds, we're turning down, based on this ratio, we're turning down the volume. You can also see now the parameter called release. When the signal goes back below the threshold, then we start to turn the volume back up to its original state, and that's done over the amount of time called release. So this is how a compressor works. If you look at the signal, you can see that we've reduced the dynamic range. The loud parts are a lot closer to the quiet parts when we do this. So we're going to leave the threshold the same. We're going to leave the ratio the same, but let's manipulate the attack. By lengthening the attack, the time it takes to turn the signal down should come out a bit. Now keep in mind that this is 500 milliseconds across for this beat. So if I change this to, let's just make it pretty big. We'll go out to 100 milliseconds for the attack. So this is the version with longer attack. So what attack is, it's the amount of time it takes for the ratio to fully kick in. Now it starts turning down the signal, but by the time we're out to 100 milliseconds, now we fully engage the ratio. Now if we go to a very short attack, then we'll see that this is extremely pointed here. So let's go to what I would consider a fast attack would be 1 millisecond. And here is an example of a very fast attack setting. You can see that the transient still comes through. So think about this if you're using compressors on drums. A drum hit has a very sharp initial attack. So you have to be careful with the transients when you're working with compressors, because you might feel like you're controlling peaks or controlling overloads by sticking a compressor on. But even if you have a very fast attack time, you can see that the transient peak can still come through, especially on very rhythmic instruments. Now, one of the things that we commonly do, I'm going to go back to what would be a typical attack setting. 4 to maybe 10 milliseconds is very common with compressors as a setting for the attack time. And you can see that we've got a big piece of the leading edge of this pulse is still visible. Now, one of the things that we commonly do to make music louder is put it through a compressor, and you can see that we're reducing the gain by about 4 dB. So we go back here and we add 3 dB or 4 dB back into the signal. And that will basically just turn it up by 4 dB. So as we're turning it down, we want to get this part back to where it's more similar to the volume of the original signal. And because the difference between loud and soft is a lot less, the whole track is going to have the effect of sounding louder. All right, so this is an example of a very typical compressor setup where we have changed the attack is pretty fast, the release is fairly slow, and we've added makeup gain. And you can see that now the waveform is about the same volume as the original, but now the lower part of it is turned up. But we also have this shaping between the release time and the attack time. And this is really important to understand because this can really affect the sound depending on the kind of music or program material you play through this. I'm just going to mute the original and we'll just play this back so you can hear how this sounds. And that's compared to the original. Really the main difference that I hear with a noise pulse is that the quiet part sounds louder than the quiet part of the original. Now, if we use a longer attack time, let's go back to that and then we'll listen to that longer attack time. You actually should be able to hear the compressor kicking in. As it starts to compress, as it takes a while for the ratio to kick in, you'll actually hear that effect. So I'm going to turn this back up to 100. I'm also going to increase the ratio quite a bit. So with a long attack time and a very deep ratio, we should get this kind of a pump effect. So that's a kind of a pumping effect. So those are some examples using different attack times, different release times, and hopefully these examples will help you understand better the concepts of attack, release, the threshold, the ratio, and also makeup gain. Thanks for watching, and I'll see you again in the next video.